Alright, so chapter 6. This is still the same unit. I combined it all for one test. So chapter 6. Rationals. Okay. Now, in maybe math 8 or 9, you would have learned about things like whole numbers, real numbers, integers, and there's a thing called rational numbers. So I'm going to just quickly give you a quick breakdown of what a rational number is. A rational number, the formal definition is any number that can be written with a numerator and denominator. That says denominator. Trust me, it's all there. So examples of rational numbers. The obvious of all, 1 over 2. That's a numerator and denominator. Another example, the number 3. Yeah, right, it's 3 over 1. Okay, rational numbers can be written as a ratio. All right, that's like the only trick I know to remembering what a rational number is. We can also do it with algebraic terms. These are called rational expressions. So instead of 3, we could also have 3x. And instead of 3x, we can also have 3x over x minus 1. All right, and this is what we're going to start looking at today. See how I did that transition from easy stuff to like, ba-bam!
I don't like this.
It's not that bad, I promise. So what we're going to do today is we're going to take rational expressions, so like something like 3x over x minus 1, and we're going to simplify them. Okay? And thankfully, in pre-calculus 20, and in pre-calc 30, and in calculus 30, most things simplify quite nicely. Okay? To make it easy. Alright, so we're going to take things that look complicated and scary, and we're going to break it down to make it look nice and easy. Alright, that's all we're doing here. Okay? I don't want to start there. Alright, let's start with this one, I guess. Okay, so in order to simplify rational expressions, it has to be the same. Things have to be the same on the top and the bottom. Okay, so you're looking for similarities here. So for example, what if I had 4x divided by 5x squared over y? There's one right here. Alright, so now I like to see what they have in common. I can't take anything out of the 4 and the 5, right? They stay as they are. But I have an x and an x squared, so I can take an x out of everything. So x divided by x, that just cancels out. It's just 1, but I just say it's gone. And then I take an x out of x squared, I'm just left with x. So when I simplify this, it just becomes 4 5x y. I can't do anything with the y because I don't have one on both the top and the bottom. Okay, how's that feeling? Good? Okay.
Not a lot of fun.
Okay, next example. Let's go with 3x all over 2x squared minus 3x. Now, a lot of people look at this and they go, oh look, we got a 3x and a 3x. We can take those out. You can't. You guys are shaking your heads, that's good. You can't do that because technically this is all one number. Okay, so you can't take out of one part of it, you have to be able to take out of all of it. Right, you can take an x out of all this. Very good, Nate. So if I look, I'm going to show all my work, just because. I can take an x out of all this, so this just becomes x, 2x minus 3. Now if I look, hey, check it out. I got an x here, and I have an x there. I can take an x out of everything now. Like so. So it just becomes okay. So what's nice about this is what I've done here is I simplified this. What I've said is this equation here and this equation here are the exact same thing. So if you wanted to, you could put a value into this guy. If you took that number and put it into this one as well, you'd get the same thing. So like if I put, let's say I said x equals 1. If I put 1 into here and put 1 into there, you get the same thing. 3 times 1 is 3. 2 minus 3 is minus 1. So that's just 3 over negative 1. If I put 1 into here, I get 3 over minus 1. Okay, so that's why we do this. It makes it easier in the long run. Now, these are skills that we're giving you here in Pre-Calc 20. That makes Pre-Calc 30, Calculus 30, all these. All right. Questions, concerns about this so far? Good. Let's try another one. Two x minus 1. Oh wait, that's not the one I wanted. Don't write that down, that's the wrong one. Here's the one I want. 3x minus 6. Oh, 2x squared minus 10. All right, so there's nothing I could like simplify out of everything all at once. So first step I do now is I simplify both the numerator and then the denominator separately, and then I see what I can take out. Always start with the simplest looking one first. Okay? When you do that, it usually gives you a clue of what will be on the what else you could take out of everything, because you're going to be looking for things that cancel out. So if you find one, it's usually going to be somewhere else as well. So it gives you a little clue what you should be looking for. So if I start here with the top one, I can take a 3 out of everything. Now, the next one, this guy here, they're a little bit trickier, right? Because I got a 2 out front. I know for a fact one of my brackets is going to have a 2x, while my other one has an x. Now remember what I said about looking for clues and trying to find the same thing? I'm willing to bet that this is going to be x minus 2 You guys see how I did that? What I saw is I got an x minus 2 here, so I put an x minus 2 there as well. And then to make this work, remember you got to do your check. I'm going to bet you that works now, if you check it. Please tell me it works.
5 and 1.
So you just take whatever's in the top bracket and put it in the
Most of the time. 9 times out of 10, that'll work.
Alright.
Okay, like not always, but I shouldn't say that's a golden rule. But if you're trying to factor something like this, we know they're a little bit trickier. And I see that I have one up here. Well, let me throw it in there and see what happens. All right, so I do my check. 5x, negative 4x. Hey, look at that. That gives me positive 1. I was right. All right, these are little clues that kind of help to make things simpler. All right, because for the most part for right now, like when you get into some higher maths, like it's not always going to work out nicely every time. And that's kind of the point. But for now, your first time out, just kind of getting used to all this, it should work out kind of nicely, okay? So now I have an x minus 2 and an x minus 2 on both top and bottom. They cancel. Just like that. And then all I'm left with is any questions about this so far? All right. Okay, I'm going to talk about non-permissible values now. That's a fun word to say. Non-permissible. Not allowed, right? So there's some things in math that we don't allow to happen, right? You can't take the square root of a negative number. With fractions, what do we know about the denominator? It can never be 0. So with non-permissible values, you have to look at your denominator and determine what values you can't put in. Okay? So these are values that you cannot use because I said so. No, I'm kidding. Because they make the denominator equal 0. You cannot have that. So basically, you just look at the denominator and you're like, well, what can't I put in here? Right? Right, Carson?
Yeah. Wrong.
No. That wasn't a trick question. Okay. So I'll start with some simple examples and we'll go from there. Like, let's go back to that one example I did. 3x, x, 2x minus 3. Now, normally you do this step first. If the question's asking for the non-permissible values, do this right away. Look at your denominator, and you got to look at things and be like, okay, when can it not equal 0? So you just go. It's just like when we found the roots of the equation, the zeros, your x-intercepts. Basically, you're looking for the x-intercepts. So you just pull the brackets apart and solve for 0. Right? Or solve for x, sorry. Does that make more sense? Okay, yeah, you kind of like, what? All right, so it's going to be x equals 0, 2x minus 3 equals 0. So this one's done. X just can't be 0, right? Does that make sense? This is like the most simplest one you can do because it's done for you, but lots of people can't get it. And I was the same way until like first year university. Yesterday. How dare you? Because if I put 0 into here, this is 0 times whatever this is, right? And what's anything times 0? It's just 0, right? So that instantly makes all of the whole bottom 0, which you can't have. Okay? This part here, 2x minus 3 equals 0. Now you just solve. 2x. I bring the 3 over by adding it. And then how do I get rid of the 2 on the x? Very good. 3 over 2 or 1.5, whatever you want to put. I'm not too picky about fractions or decimals for these. You're welcome.
Please prefer fractions.
But like it can't equal that, is it?
Oh, sorry, yeah, can't equal. So if I said what are the non-permissible values of this equation, I would just say 0 and 3 over 2. That means I can use any other number for this rather than these guys. Yeah.
So that's your answer.
Yeah.
Not that. Not.
What's that?
That's not your answer.
Yeah, these are your non-permissible values. Don't use these. Now, do we graph these?
So if I just wrote some random number down, you'd put right?
No.
That's right, but non-permissible values.
You have to solve it. Okay, yeah, we kind of graph these. So what does it mean when you can't have a 0 or an x value on your graph? What is it? We get into that later on. It's kind of cool. It's fun. All right. So let's try one more. Just for non-permissible values, okay? 2x squared all over x squared minus 4. I love this question. So if I'm looking for the non-permissible values, what part of the equation am I looking at? The denominator, right? So I'm just looking at this guy here. What kind of polynomial is x squared minus 4? Really, guys? Like what kind of quadratic is this? How could I factor this guy?
Oh, it's a difference of squares.
Yeah, it's a difference of squares, right? I can take the square root of both x squared and 4, and there's a subtraction sign there. So it just becomes 2 brackets. Square root of 4 is just 2. So then I just pull apart each bracket, make it equal to 0. Those are my non-permissible values. I can't have 2 or negative 2. Okay? How do you guys feel about non-permissible values? Just look at the denominator, factor, solve. Okay? Factor, solve. Bottom only. Good? All right. All right, let's step it up.
I've only been here for like 15 minutes.
20 minutes.
It's felt like an hour.
So for this example, we're going to simplify. And find the non-permissible values. NPV, because I'm lazy. Now, unfortunately, this textbook uses other variables besides x. They use y's and m's. Hopefully, not a lot of t's. Like this is supposed to be with y's, but I wrote it all with x's. So if it makes it easier for you, and when you're solving these with textbook questions, just write everything as x. All right. All right. So to simplify and find the non-permissible values. So now we're doing both things. So what I'm going to do first is I'm going to just factor my brackets or factor each part of this as much as I can without canceling anything. Then I'm going to solve for my non-permissible values, and then I'll simplify. Okay. Just in that order, just because it kind of just makes it easier. Like there's no sense in solving for all of this and then working it out, then coming back and redoing the question. So this is how I would recommend doing it, okay? So let's simplify this as much as we can. Real quick, which numerator or denominator would you guys factor first?
Denominator.
Why?
It's simpler.
Very good. The denominator is easier to factor first, right? There's no
5 and 2.
There's no a value. Very good. Yeah. So it's just x squared. Yeah, and it's going to be positive 5, negative 2. Now I look at the numerator.
It would be.
I'm going to have a 2x and an x for sure. Wasn't this just like the first one? It is 2. Aww. Either way. So this is going to be, well, let's go. Yeah, 2 and 4, right? Or 2 and 5. So 2x times 2 is 4x, and this is going to be 5x. Look at that. You okay with that? You kind of wince, like. Okay. Now, before I cancel everything out, I'm going to do the non-permissible values real quick. Okay? I'll do that right over here. So I take both brackets, make them equal to 0, like so. There you go. There's my non-permissible values. And now I can cancel stuff out. Now I continue on where I simplify this. Minus 2, x minus 2, x minus 2. Gonzo. You'll learn to love that, crossing things out. No, because when I bring it over, it's positive. Good question. Yeah, the crossing out thing becomes super satisfying after a while. It'll be like one of your favorite things in math class. I promise. I know that's not like awesome, but it's something, all right? Like so. Now, question. There's a 5 on the top and 5 on the bottom. Can I cancel those out?
No, you can't do that.
Good, because technically 2x plus 5 is one whole number. I have to be able to take everything out, or take something out from everything, or nothing. It really is all or nothing here, okay, guys?
What would happen if you divide it by like x plus 5, and you should be left with x?
If you divide, remember you're dividing by, you have a fraction here, right? So what's the rule for dividing? Fractions? So it becomes super complicated and gross.
Gosh, I hate that.
So why would you, don't ever do that. Don't start dividing things out, okay? So this is it simplified. Boom. So look, we took something that looked really big and awkward, and we made it a little more simple.
You don't take an x out of everything?
No.
No?
If there was like an x outside the brackets, maybe. But yeah, this is one whole number and this is one whole number. Everything has to be the same, or you can't. Okay, good question.
You sure?
Yeah. All right, now I'm going to show you one more thing today that's going to blow your mind.
Yes.
It's really, it's not that complicated, but it's so simple people overthink it. and they panic.
Good.
Good. All right. So we're going to do the same thing as before. We're going to simplify and solve for the non-permissible values. 1 minus t. Oh, just hold on. 1 minus x. X squared minus 1. All right. So first things first, let's simplify everything as much as possible without eliminating anything, and then I'll solve for the non-permissible values, and then I'll simplify by eliminating stuff, okay? So x minus 1, or 1 minus x, sorry, nothing I can do there. That's done. So it stays. X squared minus 1. That is a beautiful difference of squares. All right? Get used to seeing those, you guys. Because they show up quite a bit. There's a reason I showed a lot of these last year as well with you guys. Okay? Now look at. Let's quickly do non-permissible values. X minus 1 equals 0. X plus 1 equals 0. Now, the question is, do I have to show my work every time for this? No, you do not. You can just write them out, all right? Don't worry about it. I just show the work every time. For now. Eventually, I'll stop doing it as well. Questions about the NPVs? Questions about the difference of squares? Question for you guys. We're so close. X minus 1 and 1 minus x. Are those the same thing?
No.
No. So we can't eliminate them like that, can we? Try. But there's a way to do it.
Oh, wow.
Yes.
Oh, no.
I wouldn't leave you guys like just hanging there like this.
Divide everything out.
No, we're not going to
Yeah,
divide everything out.
divide it.
We're
Multiply.
going to, I'm going to show you guys how to rearrange stuff, and it's going to be okay. Like, think about it. If I put, let's say, like, if I put x equals 5 in there, 1 minus 5 is negative 4. 5 take away 1 is positive 4. All that's different is a negative sign, right? So we can work that through and just be left with a negative sign. All right, so what I'm going to do, I'll show you down here what this looks like. 1 minus x. If I flip them around, it becomes negative x plus 1, right? I just moved them in order. Oh, now watch this. What if I take a negative 1 out of everything? That just changes the sign on everything, right? This is where I lose everyone.
Yeah, what happened?
Okay, all I did is I took a negative 1 out of everything. Negative x divided by negative 1 is just positive x. Positive 1 divided by negative 1, negative 1. So what it does is it just changes the sign on everything, but what I'm left with is a negative 1 out front. So basically, without overthinking this, you can go from this to this. You just put a negative 1 out front. Just remember how I said if I put a 5 in here, this becomes negative 4 and this becomes 4? So it's the same thing, but one's positive and one's negative. Okay? That's going to take a little bit of time to get used to. All right? Questions about that? Okay. I'm not sure if you guys are just confused and don't want to say anything, or if it's just first class. I'm going to take the silence as we're okay. All right, so I can do that here now. So I can switch this into that. So now what I'm left with is all over Okay. Now I have an x minus 1 on the top and an x minus 1 on the bottom. They can just, yeah. Look at that. So I'm just looking at negative 1 over x plus 1. Okay?
So you would have to do that for the answer to be right.
Yes. Yeah. It's up to you guys to see. Oh, these are so close. If I just switch this one and make it negative up front, it works. Okay? You guys want to try it one like this one more time?
Yeah.
Okay.
You could do that with any number, right? Like it doesn't just have to be 1. Like it could be.
Absolutely. Like it could have been like 5 minus x or something like that. Yeah. Okay, I'm going to write this one down. I'm going to check with these guys. I want you guys to try this one, and then I'll do it with you guys. But try it first on your own. Oh, I wrote it with the M.
Yeah.
Sorry, guys. Sorry, my bad.
Or
Okay,
I guess. Because this was negative. This is positive.
let's go over this one here.
Yeah, so then over here you'd want it to be negative.
I'm going to take a 2 out of everything on top.
It's the same thing.
This is the difference of square. My non-permissible values, I'm not going to show my work here. They're just 3 and negative 3. Right? They're just the opposite signs of what's in the bracket. Now, m minus 3, 3 minus m. Oh, so close. What do we do? Remember, you switch it. If you switch it, what happens? What do you put out front? A negative 1. Excellent. That's all you got to do. So it becomes 2 times negative 1 m minus 3. I'll put another bracket there just so. Am I going too fast? Not fast enough?
No, it's okay.
The perfect speed?
Speed limit. Speed limit.
The speed limit. All right. So now, m minus 3, m minus 3. They can go. Oh, yeah. That was good. Like cracking your knuckles. Now, I got the 2 and the negative 1, though, still on top. So what happens when you multiply them together?
Oh, negative 2.
And then I'm just left with m plus 3 on top.
I just did the same.
How'd that feel?
I was really
Fine?
fine.
Never again? You'll be fine. Okay, for today,